Do you have any? Is this one? Oh, there we go. How are you guys doing? Still energized? Okay. As if none of the other speakers already spoke about AI, I'm going to bring up the topic of AI. How many of you guys here are already working with building AI or Gen AI into your applications? Show of hands. A few people already start dabbling a little bit with it. My goal for today is to help to demystify a little bit working with AI in the applications. And my goal is that I want all of you to go away from here today and feel a little bit inspired and ready to start working to build in AI features straight into your application. Because I'm going to admit, listening to the other speakers and the year that's been up until now is quite confusing. And it can be a little bit overwhelming to deal with all these different models, platforms, configurations, and how to manage it. So Firebase just launched Genkit. And the first reaction is like, we really need another platform? But Genkit is actually here to help us to make it simpler. Genkit is a platform to unify and simplify the ways we work with different models. Whether we're working with open source models on Ollama, OpenAI, or Vertex AI. Genkit is built for us to have a unified SDK and a tool set that makes it easier and more accessible to work with it. So Genkit is developed by the Firebase team. And in a very Firebase way, it is one of those things that just plug and play. It just works straight out of the box. And Genkit works both if you want to build AI features into your cloud functions or straight into your application. So thanks to the integration on Firebase, we also can benefit from a lot of the advanced authentication features such as app check. And app check allows for us to verify that all of the requests to our flows are coming from an authenticated source, which means it is our application that we have whitelisted. And it's also open source and provides they enable other developers to build their own plugins for it. It already comes with a number of plugins that allows for you to manage different type of models, which is the ones I mentioned before, OpenAI, Vertex AI, Ollama, but it also allows for us to integrate directly Vertex vector databases, trade stores, etc. So in order to make this very approachable for you, we're going to walk through a simple example, which is literally an app that we have built. It's going to be a little foodie AI companion. And this is all the code you're going to see today is all the code you're going to need in order to implement something like this. So what we're going to build is a foodie AI companion that helps us choose from a menu from a specified restaurant provided by the user. Very simple, but it's going to illustrate the point. The first thing you want to do is to start Genkit. You saw in T's presentation just before, he showcased a few of the features of Genkit. And the way to start it, you just install the package with npm and run Genkit start. It will fire up the developer UI. And as you can see on the left-hand side, you get a set of menus which is listing everything that you have configured, whether it's the flows, prompts, all the available models, tools, retrievers, indexers, embedders, and evaluators. All of these tools is going to get more clear for you if you start working with it. It is by intention I'm thinking, let's not get into what all of those things are. Let's just get started with how to build an actual application. On the right-hand side, you can see all the model configuration, where you can choose which model you want to use, all the temperature, configuration, etc. And again, there is not really any simple way to explain what is the best fit for you. Most of the things become more clear to you once you start working with it and experimenting with the configuration, because it all depends on what is the expected output that you want. What we want to do in this case is to define a system persona. We start by setting a system persona to say, you're a passionate foodie who is helping the user to make choices from a restaurant. After that, I want to try this out. So I'm saying, I'm going to a Thai restaurant. What should I order? And I think most of you or all of you are already familiar with interacting with chat-like applications, such as Gemini built in the chat prompt. And you can recognize that it's very common that we get a chat response like this, which is sufficient if you're working with a chat interface, because you as a user is just a human reading the responses that you get back. But as app developers, this is not really helpful. We want to have something that is more easy to work with, something that is structured and possible to parse in our application so we can control the data and how we present it. And as you can see, a lot of the applications we see today are text to text, or at least something to text. So what we're going to try to illustrate today is how easy it is to actually go from anything you want to structured output. To do that, we're going to introduce .prompt, which is a plugin built by Firebase Genkit, and it integrates with us in order to help managing the prompts that we are integrating into our flow. The .prompt format is built with YAML front matter, and it's using handlebar syntax for the prompting. The YAML syntax on top is defining the model, the temperatures, and it's also defining an input schema. The input schema is what tells the model what kind of input are we going to make available inside of the prompt that we can further on use in the handlebars. The handlebar syntax allows for us to access any of those input schema parameters. And it also allows for us to set up conditionals and loops, such as if you have optional input parameters, you can define in your handlebar schema saying, if this parameter available, also include this prompting, else do something else. You can also pass in arrays of values and loop over them inside of your prompt. The output schema defines how we want the model to reply back to us. In this case, we're defining, we want a JSON schema back, and I want you to pass me back an array of items. And that's going to be each of the menu choices. Saving this prompt in the prompts folder will allow Genkit to identify that we have defined a predefined prompt. It's going to show up on the left saying that we got a prompt named foodie. And the foodie prompt, as you can see now, based on the input schema, is asking us to put in a type parameter. Further on, we can see the real magic happening when we run the same flow as we did previously. Now the output schema is an array of items. So after you've figured out how you want to do your prompting, it's time to integrate this Genkit into your application. And Genkit works both on Cloud Functions and in your application. So it depends on what's most suitable for you. But you configure Genkit in the application the same way as you initialize Firebase. And in the plugins array, you're defining what are the plugins you want to support with Genkit. In this case, we're having Firebase and .prompt. For the sake of illustration, I added Google AI, I added Vertex AI and OpenAI to it also, just to show how simple it is to integrate any of the other platforms. But for the case of using Gemini, we only need to use Google AI. which comes pre-configured and it's already working for you if you're hosting it on Firebase. We can also configure flow state store. In this case, we are choosing to store it on Firebase, and the flow state store is enabling us to store flows for the state of the flow, so we can run them at a scheduled time or interrupted. The trace store, as T showed in the previous presentation, is also storing all the traces so we can look into them later if we want to debug or investigate what's happened throughout any of the flows. And the option of enable tracing in metrics, set it to true in order to store these traces into the trace store. When you configure flow state and trace store to Firebase, they are both stored into Firestore. The next step is for us to define the flow inside of our application. This would normally do, in this case, we are building a Next.js application. So this would normally be done inside of one of your hooks, for example. So you're defining the flow by saying define flow, and you're providing it with some configuration parameters. You need to provide a name, an input schema, and an output schema. You can recognize the input schema and output schema this time is matching directly to how we want inside of the prompt. It doesn't necessarily need to be, because you can manipulate the data before and after you get it out of the flow. It is just defining the parameter you want to take in as to the callback function and what that function should return. In this case, Genkit is using Zod library for doing validation of the schema. You can see it with the prefix of z.string or z.string.array to declare what is the schema that we're passing in. The auth policy allows for us to set up the policies for accessing the flow. In this case, we just want to make sure that the user is logged in. But you can also implement any of your custom authentication logic to that by checking whether the input data is allowed to be accessed by the user or anything else if they have certain roles inside of your system. The next step is to implement the callback method. In this one, we're first calling prompt foodie. That call using .prompt is assuming you're having a file called foodie.prompt inside of the prompt folder, which is in the root of the directory of your project. In the next step, we simply call our prompt with generate. We call generate and provide it with the input schema that you have declared in your prompt. In this case, it's matching one-to-one with the input schema we have of this method, so I'm simply passing in type. After that, we get a response output. And as you remember, I'm expecting to have an items in an array of strings. And lastly, just export this access to it in some method. In this case, we just call it call foodie flow with some string, and I'm going to run the flow with that string once I get it. All right. So this is the final step. We want to implement this into the UI of our application. For this application that you saw before, we just create a form, and we put where we are querying the user to put in a type of restaurant and make my order. We'll submit that selection into the get items function. We take the form data, parse it, and pick out the type and pass it into call foodie flow. And after that, we want to set the menu suggestions, which is just looping over some items into a list. And running that instantly gets us to get the array list of items into the application. So far, so good. It's already working pretty good for us, and it's showcasing the power of how to integrate Genkit. But it's questionably slightly better than it was with the text output. So let's get a little bit more creative. Let's work a little bit with the prompting to see how you can benefit from more power and control. For example, I want to expand the output schema and make it a little bit more complicated. I want the output schema to be an array of objects instead. And for the sake of illustration, I want to take those menu items and I want to classify them by drink, starter, main, or dessert. And this could be anything you want it to be. But for the sake of illustration, we do that. And we're setting up a few more rules. Make the total list of items add up to a single person meal. And if the restaurant is sushi, tapas, or other small plates, make up to 3 selections of food, but don't include a starter. But if it has individual portion foods, make it a single selection of main dish, and please do choose a starter. And you can continue on with this. Just remember that making your prompts should be very consistent and logical. It's not a problem to make them very long, but if you add too many paragraphs of text to your prompt, it can also it can invite your model to hallucinate. So try to be very concrete and exact in what you want. Classifies and order the specified menu options as follows: starter, main, dessert, or drink. In order for this to work, just showcasing how simple it is to upgrade or change your model's input and output. All we need to do this time is just to refactor the web application to add the array of objects, which is no longer just an array of strings. We're going to have 2 items coming into each list item, and it's going to be an item and a type. Running that straight out of the box, instantly get the same option, but now we get it classified by starter, main, dessert, and drink. So you can see how easy it is to just modify how your model takes input and output. And checking it with another type of restaurant, such as sushi, we can see it's now following the instructions to skip the starter and choose main dishes and adding a drink. So here's always the next step with AI. So what if we don't have that? AI is amazing to generate ideas, but how does that relate to what's actually there? How can we connect this to something that actually exists on the menu? Because in a real life situation, if you were to visit a restaurant, you would be like, hey, do you know if sushi is good at that new Japanese restaurant? You ask your friend. And if she's been there, she will helpfully say, oh, well, they don't have sushi, but it's the best place for ramen. This is not what AI will do for you. AI, in any case, would just say, oh, yeah, go ahead. We have all. So it's important for us to link AI to work with reality. But the question is, how do you go from pure fantasy into reality when you work with AI? And I'm going to say a big word for you, which T already brought up in the previous presentation, which is retrieval augmented generation. And it's a very big word for something that is not so complicated. It is simply to integrate external source of data into your LLM response. And why would we do this? Well, it has a lot of benefits. And one of them is that it's very cost effective. In order to make your models respond with some very concrete information, you need to train them on new data or make it very specific. And retraining models is both time-consuming and can be quite expensive. If you instead using RAG, it becomes very cost-effective because you don't need to retrain any models. You can also make the data very up-to-date. Since it's external sources of data, you can update the sources of data in your database without having to retrain the model that works on them. And also, it's model agnostic, meaning that if you choose upgrade your model from the newest Gemini 1.5 Flash or anything like that, you don't need to do any retraining of your model because you can test which model works best for you in terms of performance or suitability. And I know that we brought up RAG in the previous presentation, which was very technical and well illustrated. But I'm not so mentally mature as T is, so I'm going to show you with a very simple illustration for 5-year-olds. So here is the flow of how we work with LLM prompts. We have a prompt of query. We pass it into the LLM to do its magic, and we get some imaginative response back. And we all use this, and we know how this works. Adding RAG to your flow actually just introduces one more step. All we need to do is to take the prompt we had, fetch a little bit of data from a database, pass it into the LLM, and now we get an output that goes from imaginary response linked to something that is real. And we also already touched the concept of vector databases. A vector database is basically just storing a mathematical representation of concepts of the data you have put in. By processing the data in your document, you can make a mathematical concept of a vector that has a certain amount of dimensions. And to those dimensions, we can measure the distance of your conceptual query to the data that we have in the database. Sounds complex, and the mathematics behind it is, but they're making it very easy for us, since Firebase conveniently is providing a vector database in Firestore. We don't need to add anything to our tech stack if we want to introduce RAG to the Firebase project. And vector databases makes a very good fit for using in the RAG concept, because the character of your query that you use in the LLM prompting is conceptual and vague, and we need to somehow link that to real data. The vector databases is making a good fit because they're able to cluster concepts about your data and concepts about your query and match them on a point in a matrix. So to illustrate how that looks like in a very visual way, if you consider that we have a few items on a graph, we can put sushi down in the left corner, and we can put soup, some noodle soup, and a salad. And then we can imagine that we're having a certain number of concepts, such as hot, cold, raw, cooked, or anything in that terms. Adding a few more items to the graph, we can add some fried shrimp and hot tea. And bear with me, but let's say the hot tea is closer to a soup than it is to a salad. So if I was to query this database of food items saying, I would like to eat something hot on a cold day. Something hot on a cold day would be conceptually closer to eating noodles or drinking tea than it is to eating sushi or a salad. Can we agree on that? Okay. So, in order to integrate this into our application, similar to how we set up the flow, we need to define a Firestore retriever. And this one is working with the Firebase plugin that we defined in Genkit declaration from the beginning. We name the Firestore retriever, and we give it a reference to the Firestore app, the Firestore. We tell it which collection is containing all of these vector embeddings. We tell it which is the field to process for vector embeddings, and which is the field that contains the vector embeddings. And the rest is just boilerplate stuff you can set up, and it works pretty well out of the box. The next step is to update the flow we previously had. If you remember, we had the foodie flow that call directly to generate a response. In this case, we need to just introduce a simple step in the middle, which is to retrieve the documents. And I have also updated the input schema here. So now the input schema is taking a restaurant type, which was in the previously sushi or Thai. And we're also setting a mood, which is the user's food mood, such as feeling like something hot on a cold day. And we're taking that food mood and we pass it into the query to retrieve documents that are matching that description. And then we're passing this into the LLM prompt by passing in, give me some type of restaurant that matches my mood of something hot on a cold day. And then we get the output and the items that we return to the application. In this fictional case, we could pass in, give me a Vietnamese restaurant, I want something hot on a cold day, and the prompt would answer with you, why don't you have some pho? So I'm going to wrap up with that, but I want to just bring across some points with this. AI is not a solve-it-all kind of solution. Don't take AI as a way to have a solution and go around looking for a problem. AI should work in novel ways with projects that you already have. So please take the projects that you have, the problems or something, or the ideas that you already have in your mind. Maybe you have been at an obstacle before where you couldn't really go over to a good way to solve it. AI can be a novel way to approach those problems that you already have. And also don't let AI overshadow everything in your application. Don't let AI take over the whole impression of your app. Make it something very delightful and subtle. It can be something just helping the user filling out forms or automating something for the user by understanding the intention of the user. And bring it more than just chat interface. A lot of things we see today is text to text, or in some way just presenting a user-readable output. Think further than that. Think about how can you work this in the background to simple things as we did now by producing JSON outputs and operating in your app. And it can also be very subtle. Genkit can run in the background on your cloud functions, so the user might never need to know that you do things either. It can work on a scheduled time when you're updating your data to just summarize or make informed decisions on the data the user provides. So with that, that's all I need gonna leave you with. So I'm hoping that you take away from this session how simple it is to build something with Gen AI. And I'm hoping to reach out, feel free to connect with me and reach out if you have any questions. So if you want to share something with me, how you did, if you managed to make something work. So that's all from me, and thank you very much.
Thank you so much, Dennis. Thank you ครับผม